In this last recording, we'll be looking at some combinatorics questions that have to do with some 2D shapes and that are not really the standard grouping of people or poker hand questions. So in number 5, we're asked how many different rectangles can be formed by 8 horizontal lines and 3 vertical lines. So you may be thinking, well, 8 horizontal lines, 1, 2, 3, 4, 5, 6, 7, 8, oopsies, and 1, 2, 3. You may think you have to draw this out and count them all, but you don't actually, because, counting them all, this would take a long time because you have obviously one big one, and then you could say each half is a rectangle, or you have the skinny rectangle, or 2 skinny ones, or 4, etc. So there are a lot of different combinations, but if you think about it, what do you need to construct any rectangle? You need 2 vertical lines, and you need 2 horizontal lines. So if you have 8 horizontal lines altogether, and you only need 2, if you have 8 and you only need 2, and there are 3 vertical lines, and you need 2 to form a rectangle, this will give you all the possibilities of rectangles, which is pretty cool. So there should be 84. You can go ahead and count that if you want, or you can take my word for it. Number 6 says, during a meeting, everyone shook hands with each other. How many people attended the meeting if there were 300 handshakes in all? So we're looking for the number of people. We don't know our N. But we do know that there were 300 handshakes. So for our combination, we're trying to figure out how many people there had to be so that in total we got 300 handshakes. If you think about it, you need 2 people for a handshake. One person to use one hand, another person to use their other hand. So N choose 2 gives us our combination that we will then solve for N to see how many people there must have been in order to get 300 handshakes. So N choose 2 means N factorial over N minus 2 factorial times 2 factorial. I set this equal to 300. Now 2 factorial is really just equal to 2, right? 2 times 1. So if I multiply this 2 up here, I get N factorial over N minus 2 factorial equals 600. Now I can simplify these factorials using my 2 skills. So this is N times N minus 1 times N minus 2 factorial all over N minus 2 factorial. So I have my N minus 2 factorials cancel, leaving me with N times N minus 1 equals 600. So if I expand this, I get N squared minus N minus 600 equals 0. And I can factor into N minus 25, N plus 24. So N can equal 25. Oh, it looks like 215. That's Jarno's fault. Or negative 24. And of course, the negative 24 I reject. So the answer is 25. So if in a meeting there are 25 people and everybody shakes hands with everybody else, in total there would have been 300 handshakes. Okay. Number 7. Consider a circle with 5 points marked on the circumference. So here's a circle. 1, 2, 3, 4, 5. Doesn't matter where you put your points. How many triangles can be formed using these 5 points? So if you think about it, you have 5 points, and how many do you need to form a triangle? Well, you could choose any 3. So there's one triangle, 1, 2, 3, there's another triangle, etc. So from the 5 points, you need to choose 3 to make a triangle. If you evaluate, you will get 10. Let's try the next one. How many lines can be drawn connecting 2 points on the circle? Well, that's easy. You have 5 points on that circle. If you're trying to connect 2 points, you only need to use 2 of them. So 5, choose 2. Also equals 10. If you're wondering how you happen to get the same answer for both of these, oh my goodness. If you use your formula, you will see that you get the same denominator. So let's try our formula here. This would give us 5 factorial over 5 minus 3 factorial times 3 factorial, which is 5 factorial over 2 factorial, 3 factorial. In B, this gives us 5 factorial over 5 minus 2 factorial times 2 factorial, which is 5 factorial over 3 factorial, 2 factorial. So you see that our answers to A and B are the same. All right, last set of questions. Consider a regular pentagon. So pentagon, hopefully you know, means 5 sides, and regular means equal sides. So a pentagon with 5 equal sides. How many lines can be drawn connecting 2 points on a pentagon? So 1, 2, 3, 4, 5. If these are points on a pentagon, to draw a line connecting 2 points, I need 2 points. I have 5 to choose from. So this is a lot like the circle question, right? You have 5 points. You need any 2 to draw a line, right? These are all lines. So if you evaluate, you get 10. In B, it says, how many of these lines are diagonals? So if you continued and you drew all these lines in A, you would get a whole bunch of the lines that you draw are actually just sides of the pentagon. They're not diagonals. So a diagonal is not a side, right? It goes from a point across to another point. So this is a diagonal, whereas this is just the side. So of all the lines you drew in A, how many are diagonals? Well, instead of counting the diagonals, you can say, well, if there's 10 in total, and my pentagon has 5 sides, then there must be 5 diagonals. So from the total, if you subtract the number of sides, you will get the diagonals. So how many diagonals are there in a regular octagon? Well, to find all the lines that can be drawn connecting 2 points in an octagon, we would go 8, choose 2, because octagon, like octopus, means 8, and I need 2 points to draw a line. Subtracting 8, which is the number of sides, gives 20. So there are 20 diagonals in a regular octagon. So what's the general formula here? How many diagonals are there in a regular n-sided polygon? So if a shape has n sides, how many diagonals does it have? Well, still need 2 points to draw a line. And if you subtract the number of sides, if it's n-sided, we can subtract n. This will give us the number of diagonals. So if you look back, it's the same thing we did in B. It's the same thing we did in C. So E is asking us to go backwards. A polygon has 65 diagonals. So how many sides does it have? So now I'm setting this expression equal to 65. I'm going backwards to figure out how many sides there must have been. So I'm going to evaluate this over here. N choose 2 means n factorial over n minus 2 factorial times 2 factorial. I'm going to bring this n to the other side by adding n to both sides, so 65 plus n. So if I expand my n factorial, I get n times n minus 1 times n minus 2 factorial all over n minus 2 factorial times 2 factorial. equals 65 plus n. So those will cancel. Now I get n squared minus n over 2 equals 65 plus n. And there we go. So n squared minus n equals, I'm going to multiply both sides by 2. So 65 times 2 is 130 plus 2n. And then I will bring everything to one side. N squared minus 3n minus 130 equals 0. So it looks like 10 and 13 will work here. So, oh my goodness. Oh no. Oh no. Let's try undoing. Nope, that's not going to work. Okay, so n, 13, and 10. And I want this to give me negative 3, so this will be negative 13, positive 10. So n is 13 or negative 10, and we reject negative 10, which also makes sense because we can't have a polygon with negative number of sides. So that tells us our polygon must have had 13 sides. If you like, you can go back to check it by plugging it in.